Hello, everyone. Welcome to our Safer Sim webinar series. My name is Jacob Hayden, and I am the program coordinator for Safer Sim at the University of Iowa. Safety Research Using Simulation, or Safer Sim, is a Tier 1 university transportation center with the research priority of promoting safety. Our webinar series features the research happening within our center. So thank you all for joining us today. If you've joined our presentation before, you'll see we have made the switch from Adobe Connect to Zoom, but it'll still be the same show as usual. So again, thanks for joining. Before we get started, I would like to point out the chat box. We will still be using the chat box for any questions or comments, so please type anything you have there. We will address those at the end of the presentation or at the time they come in if it makes sense to. But today, our presentation will feature a unique collaboration between our center, Safer Sim, and the AAA Foundation for Traffic Safety. So I'm pleased to welcome our presenters from the University of Iowa, John Gaspar and Cher Carney, and first from the AAA Foundation for Traffic Safety, Bill Horrey. So I will turn it over to you.
Thanks very much, Jacob. Just to introduce myself, I'm Bill Horrey from the AAA Foundation for Traffic Safety. So I'm very pleased to be part of this team for the kind of inaugural study under this research program. John, if you wouldn't mind going forward a slide here. Just before turning it over to John, I just wanted to say a few words about the organizations, just for those on the line that might be familiar with one, but not the other, and vice versa. The AAA Foundation for Traffic Safety is a nonprofit charitable organization that was founded in 1947 by the American Automobile Association. Today, most of our operating budget comes from voluntary contributions from the AAA clubs, as well as from CAA in Canada and from other individuals. On the other side of the cooperative program, we have the Safer Sim. Again, many of you are very familiar with that, but this is a US DOT sponsored university transportation center. There are 5 universities that make up the Safer Sim consortium, and we're very pleased to be partnering with them. A few words about the research program itself. Really, at the core of it, it comes a kind of a shared commitment from the 2 organizations to improve traffic safety. And some of the very tangible benefits of this collaboration is that we are pooling expertise across both groups. We can share in resources and so on, and really pursue projects of mutual interest, and of which there are many. We are currently in the 2nd year of the program, and we have 5 projects underway, this being one of them. So without any further ado, I just want to thank Don Marshall, as well as all the directors of the Safer Sim sites for this opportunity. We're very pleased to be here. Jacob and Maddie, thanks for setting up the webinar. And with that, I'm going to hand it off to John to walk us through the study itself.
Okay, thanks, Bill. Hopefully everybody can hear me. I'm seeing a few nods, so I'll assume that you all can. So yeah, thanks everybody for joining this afternoon. I think we're really excited to present some of the results of this project. It was a very fun and interesting study and experience from our perspective. AAA and Safer Sim, I think, did a really great job of kind of working collaboratively together to put together this interesting project that kind of fits some of the unique qualities of both the foundation and the team members involved in Safer Sim. So we were really excited to be involved and to kind of present some of the results here today. So the project that we'll be discussing, the title is Mapping the Quality of Drivers' Mental Models to Safety and Performance. It really centers around this issue of driver understanding of technology and exploring some of the consequences of potential misunderstandings or impoverished mental models. So I'll kind of go through with a fairly high-level overview. Cher and Bill, also on the call, please jump in where I may screw things up or leave out important details. I'll go through at a fairly high level, and then please, everyone, if you could chime in with questions or comments at the end. I think we can make this an interesting discussion. It's certainly been an interesting discussion from our perspective. So before I jump in, I'd like to thank kind of the small army of individuals who were involved at different points in this project. Emily Scholl, who's now a graduate student at the University of Iowa with our group, really did a bulk of the work that you're going to see here, led a bulk of the work along with Cher, Carney. So Emily did this mostly, I think, as an undergraduate or as kind of an RA in our lab. A host of other individuals from the National Advanced Driving Simulator put in a lot of work to various components of the project. One of the interesting aspects of this collaborative project that we got to kind of team with another university within SaferSim, so the University of Massachusetts, Anuj and Pai. It was really awesome to kind of team with you guys and kind of work collaboratively on this question of mental models. A lot of what you'll see here, particularly as it relates to kind of the development of edge case simulator test scenarios to evaluate the impact of mental models, was really kind of led by a lot of the work that Anuj and his team did. And then finally, the group at in the foundation, Aaron and Brian provided some really insightful feedback on the final report, which is available, I think, online both through the foundation website and the SaferSim website. So this project deals with this topic of mental models, and for the purposes of the discussion today, I'll define these as these kind of internal representations of particular systems or technologies and our interactions with those systems. So you can think of them as our understanding of the system and our understanding of how we interact with that system. And really kind of the importance of understanding mental models is that they provide this predictive and explanatory power for how a system is going to behave. So they allow us to kind of predict how a system is going to behave in a particular situation. So with respect to advanced driver assistance systems, advanced vehicle technology, mental models have a number of different kind of important components, and you can kind of decompose these mental models into particular aspects, such as the functionality of a system and the limitations of a system. So functionality refers to how the system behaves under normal conditions, how a driver goes about operating that system. So for instance, with adaptive cruise control, how someone activates the system, changes the gap, changes the speed in that system. And then limitations refer to kind of how the system bumps up against its operational design domain, if you will. What are the limitations of where the system will function versus won't function? So for instance, if sensors are blocked in a particular situation, like with heavy rain, does that preclude the system from functioning? And how do drivers understand those limitations? So part of, I think, the challenge, and I think some of the opportunity as well with mental models in this context, is that we can actually kind of design questionnaires that can get at these aspects of mental models. So we can design questions that get at functionality by asking drivers about how they utilize different components of the system. We can ask about limitations by kind of creating these situational questions where we have drivers envision particular situations and predict how the technology will respond in that situation. And by decomposing these different aspects of mental models, we can kind of map drivers' understanding of a particular technology based on how well they understand these different aspects of the system. And it turns out when we do that, there's some kind of glaring gaps in drivers' understanding of these systems. One really good example of this is a survey led by the AAA Foundation from a couple years ago in collaboration with our group at the University of Iowa, including Cher, who's on the call. This was a large-scale survey of owners of vehicles equipped with ADAS technology. So these are people who actually have the technology on their cars. And we kind of asked, in the survey asked questions about drivers' understanding of these different components of the technologies. And it turns out that drivers actually have a fairly poor understanding of some of the aspects of their systems, particularly the limitations of their systems in different situations. So for instance, with adaptive cruise control, drivers may not understand that it may not work well on hills or curvy roads. With blind spot monitoring, the technology may not detect vehicles traveling at fast speeds. So that really kind of points, really kind of the next step in that equation is understanding how those deficits in the driver's understanding, deficits in the mental model, translate to performance in different driving situations, and particularly in situations that we might classify as edge cases where the system's kind of bumping up against its operational limits. So that's really the goal of this project, to understand how a mental model maps onto performance. So here we're looking at how a driver's mental model of one technology, adaptive cruise control, translates to performance. And today I'll talk about performance, particularly in edge case situations. So to get there, we kind of went through a number of steps, which I'll walk everyone through here today. First, in order to kind of evaluate how mental models map onto performance, we need to first be able to measure mental models. And I'll talk about our approach to doing that. And that kind of builds on some of the work from the survey, which I mentioned a couple slides back. We also had to be able to kind of generate drivers or identify drivers who had different mental models. And we kind of came up with a methodology for generating groups of drivers who have weak mental models versus strong mental models. And we kind of wanted to assess the two ends of that continuum as kind of starting point for this research. And then we actually had to kind of create situations in our simulator to evaluate performance in different situations where the technology bumped up against its operational limitations. And I'll talk about some examples of how we did that here as well. Okay, so I'll start by talking about kind of how we got to two groups of drivers with different mental models. And I think this will kind of elucidate some of the methods that we came up with for both evaluating and setting mental models. So we started by developing this initial screening. We kind of wanted to get at a really fairly basic level driver's understanding of adaptive cruise control. So we came up with this small set of questions which were meant to really assess kind of a basic understanding of adaptive cruise control. So from there, we kind of divided drivers into two groups based on their responses to these questions. So we kind of generated a group that we thought already had some understanding, and they kind of went over to our strong mental model group. And then we had a group of drivers who clearly had a poor understanding. They went into our weak mental model group. We did a little bit more then, or actually a lot more, to kind of further separate the groups. And that consisted of a combination of a PowerPoint presentation and a training drive in our simulator. So I'll start with the strong mental model group. So they, after they kind of were placed in this group, they came into the lab. We gave them this detailed presentation about adaptive cruise control, and particularly the system that we developed in the simulator, which I'll talk about in a minute. So they received detailed information both about how the system functioned and about the limitations of that system. They then did about a 15 to 20 minute training drive in the simulator with a researcher present, and that researcher was trained to provide additional training on the function and limitations of the system. So they kind of talked drivers through how to activate the system. We had some example edge cases where the system kind of bumped up against its operational limits, and the researcher kind of talked to the drivers through that. So the idea here is that we're providing a really thorough introduction to the technology. The model group, on the other hand, they also got a training presentation, but that training presentation was sparse. It was basically some high-level information about how to activate the system, what you might get from a cursory glance at an owner's manual, without much information about the limitations of the system. they then did that same training drive, except that they didn't have the researcher kind of talking them through the drive. They kind of learned through trial and error, if you will. So the researcher didn't provide any training, any input or explanations. And then at the end of that training, we gave everyone this mental model assessment, which I'll talk about in a minute. That was meant to basically kind of evaluate people's understanding of those different components of mental models, which I talked about earlier. And then we had both groups do this study drive where they encountered several edge case events, and we measured performance. Okay, so this mental model assessment, again, this is a really important component of this whole project, because in order to understand how these mental models map onto performance, we first need to kind of have some kind of quantifiable measure of how strong someone's mental model is. So this mental model assessment, which I think in the report we have an appendix that has the full assessment in there. It consisted of 3 different parts, all of which were meant to assess both the functionality and limitations, understanding of the functionality and limitations of adaptive cruise control. So we had a set of true-false questions. Again, these mapped onto to either the functionality or the limitations of the system. We had a set of free response questions where drivers kind of talked us or wrote down how they thought to activate ACC system and adjust the speed settings. And then we had a set of 3 scenario-based questions where we provided a diagram of a specific situation, and we asked how the adaptive cruise control system would behave in this situation. And this allowed us to identify how well drivers could predict what the system would do in a situation that kind of bumped up against one of these edge case, bumped up against the operational limitations. So for instance, this situation that you see here, if you have an adaptive cruise control system set, as the vehicles go around this curve, it might lose tracking on the vehicle ahead and start to accelerate. And that reflects an understanding of one limitation of the system. So again, we use this tool to kind of evaluate how good of a job we did at getting people into either the strong mental model group or the weak mental model group. You can see here on the slide the results of the survey. So this is the overall percentage correct after we went through and scored the responses. And you can see here that we're getting 2 very distinct groups of drivers. Our weak mental model group is doing significantly worse on this assessment than our strong mental model group. So this is exactly what we had envisioned, what we hoped for. Okay, so from there, we then wanted to evaluate how performance on that mental model assessment predicted performance in different driving situations. So we used our NADS1 driving simulator. In this case, we're using the simulator without motion, but we still have kind of the immersive 360-degree visuals as well as the full cab that you see here. You can actually see an interior view with Jacob driving down on the bottom. We recreated an adaptive cruise control system, and we recreated a Toyota RAV4 technology. So basically, we took kind of the owner's manual and some of the state transition diagrams that Anuj and his team had put together, and we tried to replicate as best as possible all of the functionality and interfaces of that Toyota ACC. So here on the left, you can see the actual ACC display. Here on the right, you see the display from inside of our cab. So we think it's a pretty good representation of the actual system. We then put drivers into this study drive, which was about 35 to 40 minutes on this interstate highway loop that you can see here on the left. Throughout that drive, we asked drivers to do a number of state transitions where they're changing different aspects of the system, like the speed or the gap setting. But the important part for today's discussion is that we had drivers encounter a number of edge case events throughout that drive. And again, edge cases are situations that kind of fall outside the design domain, situations where the ACC didn't respond to a situation ahead. So here you can see the examples that I'll talk about. There's an offset lead vehicle, which you can see a diagram here. So this is a vehicle just kind of offset, kind of partially in the lane. These are all situations that the ACC system isn't designed to respond to. So a driver with a good understanding of the limitations would understand that the system wasn't designed to function in those settings. So I'll talk kind of how we measured performance in these situations. One of the challenges of measuring performance and the way drivers behave is that some drivers, we found that some drivers turn off the system in these situations and others don't. So kind of classifying what's the correct response and measuring kind of the degree of the quality of response is a little bit challenging in that there's a number of different responses drivers can make. Specifically in this context, drivers can either turn the system on or turn the system off or leave it on and say steer around the obstacle. So in terms of analyzing responses to these events, I'll talk about basically what we did is we kind of grouped all the responses for this set of 3 edge cases. And then we compared individually situations where drivers responded by deactivating ACC, by turning the system off, either with the button or the brake, almost always being the brake. And then another group of drivers who responded without deactivating the system. And those responses were just lane changes that happened around the obstacle, say around the work zone. So these are the different sort of dependent measures, if you will, of performance for those 2 groups of drivers. And again, you can see that the split between drivers who did and did not deactivate the system is fairly similar for both the strong and weak mental model groups. Okay, so I'll start with drivers who did deactivate ACC. So what you're seeing here is the time from the start of the event until drivers deactivated ACC, turned the system off. And what you can see is this overall main effect where the strong mental model group is deactivating the system earlier than the weak mental model group. And what that leads to, if you look at the minimum approach distance, this is the minimum distance to the obstacle, say to the work zone or to the offset lead vehicle. So what those faster responses lead to is a larger approach distance. And you can think of this as kind of the safety gap from the hazard object. So we're getting faster responses, which down the line lead to sort of safer behaviors. Okay, so that's drivers who did deactivate the system. For drivers who did not deactivate the system, our primary measure of performance is lane change response time. So this is the time for drivers to sort of shift over into the other lane to steer around the obstacle. We had fewer responses here. So it appears that there's small differences, particularly for some events like the offset lead vehicle. But those differences are somewhat smaller than the differences we're seeing with drivers who did deactivate the system, differences between the strong and weak mental model groups. Okay, I'll show a few examples here because I think it really helps to kind of illustrate some of the differences in responses. These are differences, or these are examples that are drawn from two of the RAs in our lab. These are people we ran through during pilot testing, but we ran them through the exact set of procedures that we ended up using for the study. So this first driver is someone who would have fallen into our strong mental model group. You're going to see a couple edge case situations here back to back. The first one being the motorcycle. You can see really a pretty smooth and early response. And then we'll jump to the work zone. These weren't back to back. These were separated by some driving time. But again, you can see kind of this smooth steering response. Here you see deactivation, an early deactivation of ACC with the brake. And we can compare those responses to a driver who would have fallen into our weak mental model group. So here you'll see some indecision steering around the motorcycle. You see some hovering over the brake pedal. And then this will again be the work zone response. Here you'll see a much later response, as well as a failure to deactivate ACC. And in this case, there's actually a collision with a few of those work zone cones. And so when we look at some of these responses, what really we seem to be seeing when we see differences in response time like this is that it seems to be that drivers with weak mental models are more indecisive about how the system is going to respond and whether the system is going to respond. And this is consistent with some other earlier work from Trent Victor and colleagues who seem to suggest that it's really important to have a mental model, a working mental model of the limitations of how a system will behave in edge case situations. So one other result that I wanted to share, so if we actually plot performance on the mental model questionnaire, this is plotted against ACC deactivation time, we see this negative correlation between performance on the questionnaire and response time. So drivers who are scoring higher on the questionnaire tend to respond faster, tend to deactivate adaptive cruise control faster across these different events. And what I've done here is I've pulled out scores on the questions related to functionality on the left, the left three panels, and questions related to the limitations. And you can see that there's a relationship between both the functionality and the limitations in terms of how they map onto ACC deactivation time. That relationship appears to be somewhat stronger for the limitations component than it does for the functionality component. And what this suggests is that understanding of both of these is important, but that understanding of the limitations may be particularly important in responding to these edge case events. So to wrap up here, before questions, really, I think there's kind of three key takeaways from this first year of research. The first is that we spent quite a bit of time developing this mental model tool, and we think that we've really kind of come out with something that's a strong measure for kind of identifying the quality of drivers' understanding, at least of adaptive cruise control. Second, we really kind of came out, I think, with some key results that show that mental model quality is a strong predictor of how drivers are going to behave in these edge case situations. And I think what this suggests is that it's very important that drivers have a sufficient understanding of particularly the limitations of adaptive cruise control. And it's actually, I think it could be argued, perhaps more challenging for drivers to develop that understanding of the limitations. I think research suggests that it's often developed through kind of trial and error. So I think kind of the final point here is that that understanding seems to reduce uncertainty about how ACC will respond. And we think that that's leading to some of the faster and safer responses here. So again, it may be very helpful to kind of figure out how to kind of help drivers understand those operational limits, either through training or different techniques. So very quickly, I think there's a number of really interesting future questions that need to be considered. As I mentioned briefly with the survey results before, there's a number of other ADAS technologies, and I think understanding whether kind of what we found with ACC translates to those other technologies is a really important question that still needs to be resolved. We also, I think, need to better understand the impact of mental model quality on kind of other behavior, whether it be kind of how drivers transition during kind of normal interactions with the system or behave in other types of edge case situations. And we're in the process now of kind of taking the data that we have and kind of better understanding some of these state transitions. We also need to do more work to understand how these mental models change over time. We know that mental models are dynamic and are changing with time and experience with systems. We need to understand how those changes kind of translate into performance. And then finally, I think as we're kind of talking about as a community, I think we need to better understand how we go about setting and adjusting these mental models. Really, I think it's not a great approach, as we've seen from the survey results translating into these results, to just kind of assume that drivers are going to develop sufficient mental models on their own using things like the owner's manual. I think we really need to kind of think about how we can go about setting better mental models and driver understanding. So I think that leads into what we're doing, kind of some ongoing work for part of the second year of this collaborative project with AAA and SaferSim. The idea here is to understand how mental models change and develop over time. So what we're doing is we're getting drivers who are purchasing their first vehicle with adaptive cruise control. And what we're doing is we're tracking how their mental models develop and change over the first 6 months that they own that vehicle. So drivers purchase that vehicle, they're completing these weekly drive logs. And then at different points throughout that process, we're using the mental model assessment that we developed to kind of gauge how their mental model is changing and perhaps improving over time. And then at the end of this experience, after 6 months, we're bringing drivers in, having them do the same simulator drive to evaluate how their mental model kind of maps onto performance. After they've developed this mental model, not through our training, but through actual real world exposure. And again, that project is ongoing. And maybe Cher, you can speak to how many drivers we have enrolled at this point. With that, I feel like I ran a little bit long, so I'll open it up to any questions or comments from Bill and Cher. But thank you everyone for your attention.
Thanks, John. And yet we will open that up for questions or comments from Bill or Cher. I will add the link to that final report on our SaferSim website if you do want further details. But again, John's email address is on the screen if you want to reach out to him directly. I do want to say thank everyone for joining. This presentation will be available online on our website and our YouTube channel here by the end of the week. So if you want to go back and rewatch it or share it with any of your colleagues, you are more than welcome to. We will be sure to send that link to you once it's available. And I do want to put in a plug. This is a topical presentation. Our next presentation is actually it's next week on Tuesday from the University of Massachusetts Amherst. And that is looking at the benefits of training for advanced driver assistance systems and partial automation. So, kind of ties into, what can we do to improve drivers' mental models. So we did have a question come in. John, Cher, Bill, whoever wants to address this. How did you deal with the driver's experience with ACC in the first study when inviting participants?
Yeah, and Cher, you can correct me if I'm wrong, but I think we used prior experience with ACC as one of our kind of initial screening tools to kind of divide drivers into the strong or weak groups. So if drivers had ACC, it was one of the things we considered in kind of placement into one of those two groups, along with their understanding based on that set of questions. Cher, correct me if I'm wrong on that.
No, you're right. And what we found was most of the people who were in the stronger mental model group actually either had been exposed to or owned a vehicle previously with ACC.
Thank you. Good question here from Dr. Bencalucci. Are you planning to address diversity or cultural differences in the mental model?
Yeah, I think that's a great question. I guess we haven't planned to address it in the studies we currently have ongoing, but I see it as a really important aspect of drivers' understanding. I think one thing we really are trying to get at, particularly with the year 2 project, is how drivers go about kind of establishing these mental models over their first set of interactions. And I see that being very different across different things, like different driving cultures, for instance. The way people are kind of comfortable learning about technology varies quite a bit. So I see that being a really important topic to address in some of our future work.
Another question. Let's see. Oh, and kind of just a quick follow-up on that question, addressing drivers from different countries that may drive on the left-hand side. So definitely, I think that ties into what you were saying, John. And thank you for the question. And we did have another question that came in on, I think, the design of the study. Was the first test only ACC?
Yes. Yeah, we focused on ACC for this first study, and then we're focusing on it for the year 2 project as well. There were a number of kind of considerations that went into that, but I think we were somewhat concerned about kind of combining different technologies and things getting really complicated. So we kind of wanted to focus on a really prevalent technology, and I think B, a technology that that those survey results had kind of indicated there was some misunderstanding centered around. And also a technology that kind of had some more complex interactions in terms of how drivers go about setting it, how they change it, the number of potential edge case situations, things like that.
Great, thank you. Well, I know we are over time. One more question here, so I'm not going to let you leave quite yet. The participants were categorized into the low mental model and high mental model groups. However, beyond that categorization, were you able to explore if driving experience or experiences with ADAS correlated with their objective driving responses?
Yeah, I think Cher kind of got at that a little bit earlier. And Cher, maybe I should let you answer, but my understanding is that drivers, we saw that most of the drivers in our strong mental model group had some experience with ACC before, whereas most of the drivers in the weak mental model group did not have experience. Beyond that, I don't know that we really were able to get at that too much. Cher, is there anything that I'm
No. Okay. Yeah, no, we didn't dig into that.
And then how will you be assessing mental models for the second part of the study?
Yeah, so our plan is to use the same questionnaire, the same mental model assessment that we developed for the first study. We've tweaked it a little bit to make it a little more general. The first study, some of the questions were kind of built around the replica Toyota ACC system that we had built. So we made the questions a little more general, but much of what we're using is kind of based on that initial mental model assessment.
And as you mentioned, John, I believe that is in the appendix of the final report, if they wanted to take a look at that.
Yep, and we're happy to share the more general version that we're using for the second study, if that would be helpful too.
Excellent. Great. Well, thanks everyone. Thanks for the comments, questions, and discussion. Like I said, we will get this out to you here within the week. I will send, or I am going to include that registration link for our webinar for next week if you're interested. Like I said, that kind of deals with how training can affect drivers' interaction with these ADAS systems and partial automated driving. So we are looking forward to that. And with that, I think I'll like to take the time to thank the presenters again, John, Bill, and Cher. And with that, I think we will let you go on with the rest of your day. So thanks, everyone.